Good morning and welcome everyone to session 8 of our webinar series, Great Minds Think Alike, where we dig deeper into the complexities of mining and explore business below the surface. The reason we created this series is because the mining landscape has changed dramatically over the past few years. There are multiple challenges and trends, including more complexity, massive efficiency and productivity losses, environmental and safety challenges. There are also opportunities such as re-evaluating our methodologies, digitalization, automation, and using new technologies to better enable visibility. Initially, we gather a big picture overview of current challenges and trends, and thereafter we dive into each aspect of the complexities faced by mining companies, along with the approaches and tools to overcome those challenges. With the mining industry incurring billions of productivity and efficiency-driven losses annually, it's imperative to consistently reevaluate the methodologies we use. The mining industry has taken the same approach to mine planning, at least in South Africa, for the past 30 years. We need to employ new methodologies if we expect to get different results. Because the value chain is so complex, we've decided to create a separate session for each element in order to really dig deeper. So in session 1, we looked at the business aspect of running mines, what makes businesses successful in the mining space. In session 2, we dove deep into balancing supply and demand. In session 3, we focused on electronic permits to work, whose goal is to ultimately save lives and improve safety on mines. Crushing it, of course, is about production management. What are you planning? Focused on the unified supply chain. Can you trust me? Was about being able to trust the quality of your data so that it really becomes an asset to you. And then yesterday we went from reactive to predictive, looking at cost-effective, decarbonized supply chains, particularly in shipping. This morning we are joined by Peter McPherson from Australia, who's representing MRA, and will be discussing smart stockyard management. Can you see me? It's about the visualization that's really empowering to your people who are using these tools to do their jobs better and make lives easier. We do want you to be interactive, so please put questions in the chat box and we will try to answer them at the end of the session. If we don't get to all the questions, we will email you afterwards with direct responses. I'm going to hand over to our CEO and co-founder of RSPH, Ian Huntley. Ian is an internationally experienced business leader with over 45 years of experience in large and small corporates and in mining and industry, heavy industry in particular. Ian's very passionate about local beneficiation and the power of mining and manufacturing to empower communities and economies. Ian, over to you.
Thank you very much for the introduction, Caroline. And is it supposed to go to that? No.
My apologies.
All right. Well, while Caroline's bringing the slides back, it's extremely important, as Caroline just touched on, for South Africa to move into the 21st century or 22nd century of, let me just take control. Yep. Thank you very much. Of running businesses with a purpose. Now, the key value system within Rifle Shot over the last 21 years is to consistently improve our client's operational business performance. And many companies have put in new financial systems. They're important. They put in HR systems. They put in many, many other components. But the whole name of Rifle Shot is, why is your business being set up? So if you're a mining company, let's do mining and let's do it well. And that is our key focus on the operational and business performance. But you need to do it with a social conscience, and that talks to our value. Key in many of the things we do is the innovation and the leadership we can do through that, and the many, many tools that we've developed and trademarked. And we'll see a couple of them as we go along. Key to any business is the people. And we have this mantra we work through: people, process, technology. Your people, are they comfortable? Are they happy? Are they developing? Are they competent? And are you continually developing them? Then you can apply the processes and support them with technology. And the technology is not to replace people, it's to help them do a better job. The business transformation using leading technologies, and this is why we have partnerships such as MRA Engineering, which I'll introduce in a couple of seconds, are absolutely key on the digital journey, as is the consulting that we jointly provide to help you on that journey, because it can be very scary. Then the big buzzword today, certainly in South Africa, is the whole environmental, social governance ecosystem, ESG, and we're very strong partners. So if you're able, please join us later in the day for the next session. So Rifle Shot was established in 2001. We're a self-funded, privately held organization. We have key strategic clients. Many of them existed with me personally for a lot longer than the 21 years we've been in existence, some of them for decades. We have alliances with other organizations and a whole ecosystem by which we're able to deliver projects. But also is absolutely key is that partnership process or ethos, whether it's with our clients or with our alliance partners like MRA. We're in for the long haul, we work with them, we develop around the client needs and the industry needs as they go. Within our team, we have a huge amount of Africa and international business and information management experience. Just with the senior team, there's over 180 years, and I actually need to update my slide. There's over 50 years, not 45. One of our methodologies is, you've all heard of consulting, and most people, I think, have been burnt by it, where they borrow your watch to tell you the time. We work on the resultant process. It's key that our customers get value from what we deliver, that they get results. They're able to go back to their management and say, hey, this was a great project. So we like to be able to deliver on time, on or under budget, and be able to show real value. And again, as I mentioned earlier, the operational improvement focus is key. Rifle Shot is a member of the Madala and Associates Group, which is a BE, Black Economic Empowered, Black Women-owned Level 1 company, and as a result, Rifle Shot is a Level 2. So I'd like to introduce Peter McPherson from MRA. He's one of the directors, and to introduce you to the whole stockyard management and that side of it. And one of my key customers, used to come to me and, well, he'd use slightly more colorful language. Where is my stuff? Can you see it? And I think that would be a good intro to Peter. He's got lots of experience, qualified engineer, electrical engineer, understands safety, chartered status, multiple projects in Australia and rest of the world. And I think from a day-to-day point of view, no better person than Peter to introduce the smart products. Over to you, Peter.
No worries. Thanks, Ian and Caroline, for the introduction. I'll just share my screen now. Alrighty, so for today, for an introduction into our system, we're going to go through a brief presentation that is an introduction to MRA and our smart product range. And then we'll do a live demonstration of our Stockyard management system at one of our coal export terminals in Australia. So an introduction to MRA. We are a systems integrator engineering firm. So we have 25 years experience in performing PLC and SCADA automation for the materials handling industry. So we've worked with all of the big miners and export terminals in Australia in developing PLC SCADA for conveyors, mobile machines, ship loaders, dump stations, and the like. So we have a great amount of automation experience, domain knowledge in that area. And that is where we've built our smart automation products upon, and all of our decision making and the strategy for our smart products is based upon our domain knowledge of control systems. So we always want to keep the control aspects of the system in the PLC, so it is able to be open and maintained. All decisions are to be made in the control system where site personnel can see and be able to maintain, modify as required. And that is one of our big points of difference compared to other competitors on the market that drop in a full black box style solution where the owner has no control. And if they want to change a bit of text or a button here, they have to ring up the vendor to get that changed. That is not the case with our solution. So part of our smart automation products, we have three key mature products that we have developed and have since deployed at a number of sites. We've got our smart stockyard management system that we'll be focusing on in today's presentation, and we'll briefly touch on at the end of our presentation some of our other products, which is our ship loader to vessel anti-collision system, which is our first step to automation, which is to ship loader or ship unloader automation. So we start looking at vessel list and drift and all those systems as well. And then also our train loadout and dump station automation, where we can 100% de-man operations and optimize operations for train loadout and dump stations along the way. All of our smart products have similar concepts. They're all about adding eyes to the control system. So building upon the existing control system or the new control system, depending on the project. And our go-to is LiDAR. So we add 3D LiDAR into the control system to make better decisions. So we treat all of our systems as a smart sensor, where we will receive quite a lot of information from our scanning technology. We will receive inputs from the control system. We will analyze all of that information and then provide key information back to the control system for important decisions to be made. In using LiDAR in industrial applications, you need to be able to deal with dust, rain, steam, fog, and the like. And that is where MRA has invested a lot of time and effort in developing a proprietary filtering techniques to overcome that. And that allows us to overcome the issues that you typically have with LiDAR in those outdoor harsh environmental conditions, where in the past, a lot of people would utilize radar technology, where you have less accuracy, but you don't have as much issues with environmental conditions. But utilizing our proprietary environmental filtering, we can utilize the more accurate 3D LiDAR that has gone leaps and bounds over the last number of years because of the automotive industry. They have come down in price. They've come down from about $100,000 US price point down to $5,000 US. So they are a quite cheap sensor and low maintenance. And you get millions of data points that we can build up an accurate model, whether that's of a stockyard or a ship or a train, depending upon which one of our systems we're talking about. And we're agnostic to brands as well. We are not a sensor manufacturer. We are a engineering company. So we can determine what is the best sensor for the application and utilize that. The last point on this slide is our systems are all agnostic to the material as well. So we have come out of the east coast of Australia. That is where MRA is located, and all of our initial projects have been. So we are heavily coal focused and our background is in coal. But more recently, we have been able to deploy these smart products in iron ore, bauxite, and most recently in potash as well. So it shows that our system is able to be used in all of those areas. So as mentioned, our MRA's background is out of Newcastle, Australia. So the Hunter Valley, which is a very large coal export region of Australia, the east coast of Australia, approximately 2 hours north of Sydney. And that is where we've pioneered and developed our systems on some of our coal terminals that are close to our office that we have great relationships with. One of them being Port Waratah, which is the world's largest coal terminal. Last year, 65% of Australia's coal exports were processed through our smart automation technology. So it shows that we are quite a mature vendor. And we've got some stats here since 2015. Our rail automation systems, so train loadouts and dump stations, we've processed over 11 million rail wagons, and our smart stockyard management system that we'll be speaking about today has processed over 1.25 billion tonnes of coal. So that's valued at approximately $2.5 trillion worth of exports. So it shows the maturity of our systems, and these systems have allowed us to be the primary systems integrator at a number of East Coast ports in Australia. So 5 of the 8 East Coast ports, MRA is now the primary systems integrator performing all of their PLC and SCADA work. Our smart stockyard management system is a modular system, and that's what we outline in this diagram here. It shows our system can be deployed on a site that is full manual, so a stockyard that is 100% operator controlled, and we can step that stockyard through to all the way to advanced automation, or we can stop along the way. This, or some sites that are more mature, that may already have some semi-automation or are already 100% automated, we can then take them the rest of the way in the journey to get full optimization or quality tracking or planning, whatever the user outcomes are. As if this is a modular solution, not a one-size-fits-all, we can cater the product for any site. So any of these modules are optional. So if a site is more focused on quality, we can deploy our quality system. But if that's not of interest, we don't have to deploy that module. And we'll speak a little bit about some user cases in differing industries shortly. But what this also allows is if a site is not interested in demanning, our tools can be used to support the operator. Or vice versa, if they are looking at demanning, we can utilize our more advanced technology to perform that and get the full optimization. So we can work in with the requirements of each site. So the next couple of slides talk about some industry cases where our Stockyard management system and our other smart products are applicable. So our first one is export terminals. In export terminals, it's all about efficiency gains. So we've got a couple of examples here from Port Kembla Coal Terminal, which is the site we'll be doing a live demonstration on shortly. We were able to increase their gross loading rate by 47%. And that was taking their site from a 100% manual operation through to a automated solution. And then more recently, we've added scanning technology and optimized their operations. The second point here is in relation to a second site, which is this 3D visualization image has been taken from there, which is Abbott Point Coal Terminal in far north Queensland, where they had a automated stockyard, so a PLC automated stockyard, utilising bucket wheel power to determine when was the best time to turn around. By implementing our smart turn solution, we're able to gain an extra 11.3% of extra gains to that site. So that site does 55 million tonnes per year. So an additional 11.3% is a quite a large throughput gain for that facility. The last stat here is also from Port Kembla, which is they're saving by having our system provide them with advanced start information for each stockpile. They save 30 minutes per each starting on a stockpile or their bench changes. So it means their first swing of the stockpile is 100% efficient. There's no air swings or light cuts to get started and moving on the stockpile. Increased safety of personnel. So utilising our tool to avoid the need to be going out into the stockpile, which can reducing the need to be driving vehicles out in the stockpiles or walking around to visualise what is out there. This can be all done from the office environment and also is useful for remote operations as well. Reduce stress on bearings. We have another slide coming up in the presentation that goes into a bit more detail about that, but it's all about having greater awareness of the stockpile. We can keep consistent loading upon the machine, which means we're not flexing the boom, we're not stressing the bearings on the bucket wheel or the slew bearing, and we can get consistent loading onto conveyors. So you can increase the life of your $50 million asset, which can be very useful. Quality management as well, that is applicable to more of your owner-operator export terminals where they own the full life cycle. So it's all about being able to blend into the stockpile and blend out to ensure that they meet the correct requirements. And we do have some slides coming up on that shortly in more detail. In regards to the mine to port workflow, we can provide automation utilising our train system at the mine to load the train with a efficiency or accuracy greater than 97%, and that can be in a manned operation or a demanned operation. And then we can provide some safety features of that as well, removing the operator from that high-risk area, either back to a remote operating centre or deman altogether. We can be monitoring for derailments as well and detect them and stop, which is some asset protection. We can also adjust our automation based on carry back from the port facility of from wherever the material's been dumped at. So is there residual material in the wagon? We can adjust the batching accordingly. So that's applicable to the mine site, and obviously our stockyard management system from the previous slides is applicable to the mine site as well if they have mobile machines. Then moving on to the exporting of the material at a port facility, we can also provide the automation of the ship loader and also a grab unloader, depending if it's an import terminal as well. So we can provide a full anti-collision system, ship loader or grab unloader to vessel anti-collision, where we can slow down and inhibit motions. So essentially placing a dynamic protection zone around the vessel so we don't run into it. And also more advanced automation where we can start looking at vessel list, vessel drift, automatic relocation to other hatches as well. Our next user case is thermal power stations. So where we can be of use here is in two areas. One is being able to monitor the quantity of material in the stockyard to ensure they have enough resources to feed the power station. And this is very much applicable to steel plants as well. It's a very similar user case where we can show exactly where the stockpiles are and how much quantity is in them. But then more importantly, we can also track the quality of that material throughout the stockpile. And we'll speak about that more in coming slides. So this is important with the ESG measures that are happening all throughout the world. We can monitor, we can track the quality of the material down to 0.1 cubic meter bricks in the stockpile. And each of those bricks can have quality information appended to them. So what that allows thermal power stations or steel plants to go away from, instead of having what is my average quality across my whole stockyard or a certain stockpile, we can tell you what is your quality for a single brick down to 0.1 of a cubic meter. So we can then use that to more accurately blend material into the stockpiles and out to ensure that you're getting a consistent and targeted blend of material into your thermal power plant or your steel plant. So that allows you to reduce your environment emissions by having a more efficient blend of material coming in. You're not burning high quality coal and then at the other end of the stockpile burning low quality coal. You have a nice consistent blend throughout that is measurable. So you have a way to measure that, report on that. It's audible. So it's quite a powerful system in that space. As mentioned previously, the bucket wheel protection is all about being able to longevity of a machine and prevent damage. For people who are familiar with mobile machines, it is very easy to for material to avalanche down and bog a machine, or also to drive into a stockpile and cause high load or high shear events on the machine. Each one of these machines we're talking about have quite a high asset cost, over around that $50 million US. And the long lead items of those are the bearings. So the slew bearings and the bucket wheel bearings. So being able to know what the face of the stockpile looks like and being able to adjust the reclaimer based on that allows consistent loading upon the boom of the machine, so you don't have boom flex or warp, and then not leaving the stockpile at each side as well. Provides consistent loading onto your conveyors as well. So it's able to provide longevity to your machines and provide downtime with very costly maintenance issues. We've had a number of clients that are interested in our system purely upon just this, due to the damage and issues they're having with their machines. Onto 3D quality tracking. So as mentioned, each of these, the stockpile is broken up into 0.1 cubic meter bricks, where we have database information appended to each of those bricks of quality information. So that's coming from any information that is available from the Stockyard, whether that's from online analyzers providing us live information about the quality, then we can show that real time in our environment, or whether that's coming from a sample station, potentially 12 or 24 hours later on, we can then post-append that information automatically into our visualization as well, which, as mentioned in the previous slides, that allows the ability to be able to plan a reclaim task, as you can see here in the light blue, and be provided with what quality will be achieved in this section, and then what will my stockpile look like once that job has been completed. You can also search through the stockpile to find a certain material or grade, and by scanning cross-sectionally through the middle of the stockpile as well, or longitudinally. You can hide certain grades as well. So this one is from an iron ore facility where they're showing iron content, but you could also choose to show silicates or any other content of the stockpile in this environment as well. And the bottom image here is from a thermal power station in Australia, where they were after being able to show the age of the stockpile. So how long has that 0.1 of a cubic meter brick been in my stockpile for? Because they were having issues with the coal turning solid or losing its quality. So being able to view in the visualization where is the oldest material, they were able to then target their reclaiming to ensure that they're reclaiming that first. We also have the ability to track the quality from the whole mine to port value chain as well. So we can track it into each wagon of a train and ensure that you're getting a consistent blend and the right quality targets. Once again, this is from iron ore, so it's showing for the entire train what is the iron content, silicates, etc. of the entire train. Or we can also look at it here per wagon, so we can see what is this wagon made up of. This is what is shown here, and is it meeting the quality targets of that consignment. We can then track it into the stockpile, which is shown in the top right, and then all the way down into the hatch of each vessel as well. So you know, is the quality met in each hatch, and then overall for the vessel. So you can see here in this case, the iron content was was over target. So it's all about then the reclaimer can automatically be adjusted to ensure that they're just meeting the right target, not overselling or underselling their value. So what we'll move on to now is a live demonstration of our Port Kembla system. Port Kembla is a coal export terminal that is an hour south of Sydney, Australia, so on the east coast of Australia. They have 3 stackers and 1 reclaimer, and they export approximately 14 million tonnes per annum of coal. We deployed our system in 2016, and initially it was just a 3D modelling system on their existing machines that were built in the 1980s. In 2017, they replaced all of their mobile machines. So at that stage, we automated all their mobile machines. We provided a machine-to-machine, a sill-rated machine-to-machine anti-collision system. And then in 2021, we added, so they operated for 4 years without laser scanners. In 2021, we included scanning to get greater optimisation. So the key outcomes for this site was they were able to perform better planning, so they could take control of their site in planning. They could do a lot more tasks than what they previously could, and they can see what is my stockpile going to look like in the next 12 to 24 hours, so they can better plan and work out, will they have capacity on the ground to take those next consignment of trains? Where will I have any clashes between stackers and reclaimers? They save 4 hours a day in automating by utilising our advanced start positions. their gross loading rate improved 47%, and they could operate 2 machines on the same stockpile. That was previously a limitation. So the 2 machines can operate within 30 meters of each other with our system without any issues. So you can be stacking and reclaiming on the same stockpile at the same time. So I'll bring up our live system. So this is our 3D visualization environment. It's a Windows-based application that's been developed in a gaming engine and can be used anywhere on site. So a lot of our sites will place it on a large TV screen in the control room, for example, where they can, where their operations, day-to-day operations people can see exactly what the stockpile looks like or what the stockyard looks like. Typically utilised by planning and logistics as well, but also can be brought up just on any engineering workstations and the like as well. It is a pan tilt zoom environment, and you'll see that as I perform the demonstration. So you can hover and zoom around and look at the stockyard from any angle that you would like. We provide, as you can see, information about where is each machine currently located. So there's a 3D model of the machine in there that is real time moving around based on where the machine currently is. As you can see here, we show separation distance from the boom tip to where will it collide with the stockpile, and that is passed on to the control system to be used by the machine to slow down and inhibit if required. When we hover over each of the stockpile zones, we get information about that stockpile. So for example here, stockpile 25, its zone is between the 110 and the 300 metre mark. And there's 42,700 tonnes on the ground. They could stack an additional 35,000 tonnes if need be. If there's dry weather and they want to utilise a mode called overstacking, they could fit an additional 50,000 tonnes of material on that zone. And the density of that stockpile is 1.3 cubic metres. And this is customisable, so any key information can be provided on here. It might be what is the vessel that this stockpile is allocated to, for example, or what is the name of this coal, what mine has it come from, or who owns this coal, for example, depending upon the user and what they want to display. In our menus, you can turn on and off a number of these. So, for example, that information we're just looking at there, we can turn off those stockpile zones so you can just see the stockpiles, for example. We can turn off the long travel markers that show you the chainage along the stockyard. So in relation to the stockpiles themselves, the colours represent the height of the stockpile. So Port Kembla operate with 4 reclaim heights. They have an upper bench being the gold, blue and red being the middle benches, and green being the bottom benches. So straight away, you can see whether a stockpile is at full height, such as these ones, or whether it's slightly lower, like this stockpile at the top right here, that is only has a blue, doesn't have any of this top bench, or this pimple looking stockpile here as well. The way we build our stockpiles is a key feature of our system as well. So we do that we have 2 methods of building our stockpiles, which is very much a point of difference of the MRA system, is we build a volumetric model, and you'll see some of the stockpiles are very smooth. So we know from the control system the position of the stacker, where the boom tip currently is, and how many tonnes per hour of material is currently leaving the boom. So we can model that in our system. We know how material flows and how it builds into a stockpile. So we can model that without using any scanning technology. That's purely using the information from the existing control system on the site. Then, and as mentioned in the previous slide, we operated this site for 4 years purely with that technology. It wasn't until last year that we added scanning technology to the reclaimer, which is where you see stockpiles that have rough surfaces, like, for example, along the side of this stockpile or on here. So the reclaimer, which is currently parked up at the moment, has a LiDAR scanner mounted on each side of the boom. And as the machine is reclaiming, it is updating the surface of our model. So it goes from this super smooth model to roughs, all the bumps and hills and hollows that you have with a live stockpile, which is probably best shown in this stockpile down the bottom right here that's been partially reclaimed. You can see the face looks like the true face of a stockpile as it's been scanned by the LiDAR scanners. And when the reclaimer is operating, you can see that in this environment too. You can see that LiDAR scanning. So this is what we call our stockpile view. One other key feature is up the top right hand here. We have the XYZ coordinates. So you can hover over any point and see the XYZ coordinate of where your mouse is. So we can see that the stockpile at this location is 14.98 meters tall, and it's at the 610 chainage mark for this facility, and an offset of 31 meters from their Y coordinate, which is down here on their roadway, is where their zero mark is. They also have, in our 3D environment, we also have our planning view, which is for sites where we've done the automation. You can come in here and view the planned tasks in this environment. So we can look at, you can come in here and select a stockpile. And now we can see what are the planned tasks for this stockpile. There is this light blue line down here is depicting a stacking task. So they currently have a stacking task allocated to this that the control room can select and automatically operate. That will stack material from a source of road/rail to a height of 18 meters, offset the center line 2.5 meters to the east, and it will continue stacking from left to right. So what that will do is our system will tell the stacker to set up right at this point here where it last left off, and the stacker will continue and it will fill in this gap here. Where on other stockpiles, for example, you can see where the stacker is set up now because it hasn't quite got to full height in this area. So it's going to stack from left and it's going to stack all the way and it will bury this pimple is the task that will be happening there. And this stockpile also has a number of reclaim tasks currently planned as well, which is what these orange lines are showing. So they're doing 4 bench reclaiming. This bottom task is in B quadrant, left to right. And we also have 4 bench reclaiming C quadrant, left to right. So the operator from the SCADA screens can automatically select these tasks, select start, and the machine will automatically relocate to the most efficient location of the stockpile and commence that task. And we also have our machine view. So these are views that follow the machine around. So you can select your machine, say stack reclaimer 3, for example, that we already have, and we can go through a number of views. So top down, machine front, machine rear, for example, and they'll follow the machine around all day long. So you can choose any of the other machines as well to see what's going on. And you have a bit of machine information on the left-hand side here as well. So that is what we can see in our live view. So that's currently what is happening at 6 p.m. on site in Australia at the moment at Port Kembla. What we can also do as a part of our system is we have a 30-day playback functionality. So we can move out of our live mode and we can enter our playback mode, which, as mentioned, can play back 30 days of operation. So if we go back to yesterday, for example, what it'll do, it'll load the stockpiles as they were yesterday. So you would have seen some of the stockpiles would have moved, and we can do that back for 30 days. If we go to this morning, because I know there was a reclaim task on the morning of the 26th, So if we select that and press play, we can then, if I zoom out, we can then be able to see that the machine has moved, and that will show us exactly where the machine was at early hours of this morning. So moving along, we can see the stockyards will move around based on that information. What I'll do now, whilst we're talking about operations, I'll just bring up their SCADA screens to illustrate the control aspects before we look at actual reclaiming. So from our system can provide information into their customer portals as well. So that provides information such as we can, as you can see here, is the mesh, stockyard meshes of, this is the a snapshot of what our stockyard looks like. As you can see, from our playback and our visualization and our and the customer portal, you can see the same image is shown there. And this has been the way Port Kembla can provide accountability back to their customers. So they have 5 to 6 miners operate through their port. So they have access to this customer portal, and they can see at any time exactly where their material is, what does their stockpile look like, how many tons are on the ground. So it gives them full accountability and traceability of what is currently happening. And then the stockyard can be filtered that each customer can only see their material. They can't see another competitor's material. And that is the same. They can come in here and look at scheduling of trains and ships, and they can see how much material's on the ground. So our system has API interfaces into web interfaces such as this. So it's quite powerful. Then it also integrates into the control system. So these are the SCADA screens that MRA developed for this site, where the whole site is controlled. So it provides for example, each of the machines have SCADA screens where you can see the position of the machine, where you can operate the task from, and then the ability to be able to go to from their dumps. This is their dump station screens, for example, where they can automate, where they can run through their trains to inload material. All the way through stacking is where they can see exactly what's happening in that area. And from these screens is where they select the jobs that are out of our system and operate those. Because our 3D our visualization is purely a read-only environment. So it was just a bit of an information into how our system integrates to the whole life cycle of a site, where we can provide information to other databases or other reporting tools, and also how does the system control. So back to reclaiming and our 30-day playback. So now I've shown on the SCADA screen how the operators select jobs and run the jobs. Then this is where you can see them actually operating on the machine. So this was the 25th. So yesterday, early hours in the morning, Reclaimer 3 was currently operating. So this is running at real time. You can also speed up this playback functionality as well. So we can go, that's 30 seconds per second, and you can see the Reclaimer's operating at a quicker speed now, which makes it a bit more useful for demonstrations such as this, or even playing back, why does my stockpile look like the way it is? Even fault finding of why did a machine do what it did, for example. If we go to the top-down view, it's probably the most relevant here, is we can see now the Reclaimer reclaiming and doing its task. These blue bars is is a part of MRA smart turn system. So the dark blue represents where we're telling the control system is the best location to turn around for this current swing. And the light blue is where you should turn around for the next swing. And that's where we get our large optimization gains, is by being able to provide accurate knowledge to the control system of this is where you should turn around to get the most efficient reclaiming without leaving the material and putting that flex on the boom that we spoke about previously, and getting the most optimized reclaiming. And on these top and middle benches, we can be a bit more aggressive. You can see we've left some blue material behind, and this is configurable in the control system, how much you want to leave behind in these benches, because that's just going to collapse to the lower bench, where in the bottom bench, you may want to clean it all up because there may be a different product. But this really shows the power of our 30-day playback and also our smart turn system, where traditionally a reclaimer would leave the material, then the sensors would detect I'm getting no tons per hour. So it would then turn around and head back the other direction, which is causing that strain on the machine, as well as gaps in coal flow. So hence inefficiency. So purely just this smart turn system, as highlighting our slides, provides approximately 11% throughput on a fully automated stockyard, where all of our automation, setting up, turning smarter, etc., and better planning can provide throughput gains of that 30–40% plus mark. And also you can see here some the information we're passing to the control system, the interface of what is going back there for that, as mentioned, that full control inside the PLC. So that's the completion of our demonstration of our of the Paul Kembler system. There is a lot more to show. Typically, I'd spend a couple of hours with our clients demonstrating the applications. We can go to a number of other sites as well that have different setups and different systems. Like, for example, Abbott Point in far north Queensland, they have 6 stacker reclaimers and operate 55 million tonnes per year. So you can see what the visualization looks like with 6 rows of stockpiles and a lot more material, and a lot bigger stockpiles as well, multiple stacking techniques. They do windrow and cone. So it just shows the flexibility of our system. So that is the completion of the overview of our smart stockyard management system, and more than happy to work through some questions on that in a moment. I just wanted to briefly just spend the next couple of minutes going through just a very quick highlights of our other mature smart products, that being our ship loader automation. So being able to provide anti-collision for ship loaders and grab unloaders by building a 3D model of the vessel in front of them. Very similar concept to how we do stockyard management. So we deployed that in 3 ship loaders in Australia and 1 in Canada. Then the next step in the automation roadmap is the ability to be able to start determining what is a hatch, where is a hatch, is it open, is it closed, how many hatches are there on the vessel, what hatch am I currently in, and then is the vessel moving, is it loaded too much in one way. So you can see that in this bottom image here, the list of the vessel, or the pitch of the vessel, or the draft of the vessel, or the drift. Is the vessel moving up and down the wharf? So a system can provide all of that information, which is all the enablers to then provide full automation, where you can then, it's just like a stockpile. Then you know where the stockpile needs to be. You know the shape of the hatch and where it is, then you can load it following that recipe that is best suited for that hatch. So this is just a couple of pictures here from the system we deployed in Canada, which was a heavy metals system. So it's a spout teleshoot style ship loader that operates small little vessels with lots of cranes and deck gear. and being able to provide a separation distance back to the control system for slowing down, inhibiting, and also it provides the operator a tool to be able to remotely operate the ship loader. And then it's that step towards automation if that's what is wished by the client. So increasing the safety of personnel because it allows them to move the operator off the boom tip to an office environment. You're protecting your assets, so you're not colliding once again, a $30–40 million US machine into a vessel and causing considerable downtime as well. You're increasing efficiency as well, as part of that system. We do have some videos that we can provide as well that show some demonstrations of that system, but we're starting to run a bit short on time. This shows the point cloud of what our scanning technology can achieve. So you can see profiling the material inside the hatch, seeing the edges of the hatch, and then being able to analyze that. And this is the LiDAR scanner that we utilize. And it's the same scanner that we use for our Stockyard management system as well. So we mount one of these on each side of the stacker reclaimer, as mentioned, for our Stockyard scanning. We're in our ship loader. Depending upon the machine, we may have anywhere between 5 to 7 of these highly accurate LiDAR scanners, which have no external moving parts and are quite inexpensive compared to others on the market. Our last automation product is our train loading solutions, where we can provide accurate information about where the position of the wagon is in relation to a train loadout facility or a train dump station. So where is the start of the wagon? Where is the end of the wagon? What does the profile of the material currently look like? All the residual material coming into the train loadout. And that provides quite advanced information to the control system to more efficiently load wagons. And that can be used to provide to a manual operator that additional information, or it can be used to 100% automate the train loadout and dump station as well, that we've done at numerous installations. We've been able to successfully 100% demand those operations and get loading efficiencies of greater than 97%. So this, and you get consistent loading between your front and back as well. So you can get, there's a big push in Australia for consistent wheel loading on bogies to limit the amount of wear and tear on the rail infrastructure. So rail haulage providers in Australia get fined based on if they have a lot of material at the front of the wagon and not much at the back. Penalties can be applied for that. So being able to get consistent loading, which is better for the train wagon, it's better for the rail itself, and reduces the risk of derailments and the like as well for having uneven loaded wagons. So that concludes my presentation about MRA and about our smart products, focusing on our Stockyard management system today. So we've got any questions at the moment for our system?
Thank you very much, Peter. A couple of questions. You said earlier that this integrates to existing planning and logistics tools. Could you give some examples of what those might be?
Yeah, that's a great question. So our system can integrate with many third-party systems, because our system background is a database. We have an API connection where we can connect to a range of third-party systems. Ones that we have successfully integrated with in the past is ION's ViewMaster port view system, where they provide information to our system in regards to the train schedule and the shipping schedule, and the allocated stockpile zones, then we can bring that into our system and we can operate upon those tasks. So the ION system is all about long-term planning. So they're looking at weeks out, how many trains are going to be coming into my facility or trucks, how many vessels are going to be loaded in the next month. Our system is all about taking that information and then operating on that and then reporting back into their system what actually happened. So we do the live operations and then report that live information back into their system for reconciliation. And we can show a lot of that information in our visualization at the moment. So we're currently doing a big deployment with ION at Abbott Point Coal Terminal in Queensland, where we're working hand in hand and integrating those two solutions together. So we have a strong partnership there with ION's system. We also have runs on the board with systems such as Aviva's Ampler for downtime delay accounting systems. We can provide more information into those systems and into a number of SCADA applications as well. So yeah, there's a lot of capabilities there in integration with other systems on the market.
Thank you. Tikaona is here from Zambia. Do you happen to have any questions at the moment before I ask my next?
Not at the moment, just trying to understand and find my spaces within the whole spectrum of what you guys are presenting.
Thank you. Then, Peter, in the first site reference you gave, you said there was a 47% increase in gross loading rate by going from manual to fully automated. Can I ask what the effect then is on personnel?
Yes, that's a good question. With the as the system is quite modular, and highlighted in one of the previous slides is that we can work with the client to determine what is their end goal, what are they trying to achieve, and then we can then apply the most applicable modules for that will help the client meet that end goal thereafter. And that may be providing just visualization, for example. They may just want to know how much information, how much material do I have on the ground, or what is the quality of that? And we have modules to do that. So that does not impact manning. We can provide key information to an operator, such as, we recommend you should turn around now. That doesn't mean that has to be automated and actually control the machine. That can just be a heads up or just some information as a tool to be provided to the operator that's using the machine. But then also, if the client's goal is to, and just from that will provide quite a efficiency gain for the site, just by having that key information, that better visualization of what's going on. The operator has a limited view. You can see the cabin of this reclaimer here. You have quite a limited view of what the stockpile, where it is, because you have this big bucket wheel in the way, or what's over the other side, or what's coming up. So having that extra tools for the operator provides quite an efficiency gain in itself. But then if the end game for that client is to automate, we can then take that information into the control system and start to perform automation tasks to deman. And that may be, you may look at demanning just the setting up of a stockpile, and then the operator still reclaims the stockpile, or vice versa. The operator still sets up for the stockpile, then the system automatically reclaims that bench, for example. So our system is customizable and modular, so we can work with the client to meet their user requirements, not jam a one-size-fits-all solution down their throat.
Okay, thanks. And then also you spoke about cutting through environmental kind of pollutants, if you will, like rain and snow and dust. Can you detect spontaneous combustion hotspots in the stockpile?
Yes, that is something that we've seen a lot of interest for, and we do have a module for that that we are in the stages of completing that module and rolling out. So by the end of this calendar year, we'll have the system in place. So we've done all the proof of concept work and development for that, because we see that is a big interest in the market, is being able to, in the coal market, is being able to detect thermal combustion or spontaneous combustion in a stockpile early, and we'll be able to display that in our visualization environment and then provide that to the control system for action to be taken, whether that's whether they need to take a dozer out there and tramp the stockpile and to reduce the oxygen in the stockpile to put out that hotspot, or whether it's to take a different action. So yes, that is something that is on the leading edge of our system, and we are in the final stages of deploying a module for that. So yeah, that would be utilising different sensors, specific thermal cameras compared to our LiDAR sensors that we use for scanning. Hopefully that answered that question.
Yes, thank you very much. Are there any other questions from the audience? Then I'm going to say thank you very much, Peter, for that. And thank you, everybody, for your time. Our next session and final session will be this afternoon at 3 o'clock. Details are on our website. I'm going to put the registration link in the chat box now. And if you're able to join us then, we look forward to seeing you. Otherwise, we'll be following up with you soon. Thank you very much, everybody.